Welcome back. Now we're looking at example 2. We have a different equation here. It's f of x equals 4 to the x. Our base number is bigger than 2. So we're going to pick some values of x to throw in here. Maybe we'll throw in negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. Negative 3 will be 4 to the negative 3, which will be 1 over 4 to the cubed, which will be 1 over 4 times 4 times 4, 64. That's a pretty small number. 4 to the negative 2 is 1 over 4 squared is 1 over 16. 4 to the negative 1 is 1 over 4. 4 to the 0 is 1. 4 to the 1 is 4. 4 squared is 16. 4 to the 3 is 64. 4 to the 4 is going to be, that's a big number, 4 to the 4, 256. So this gets pretty big pretty fast. Our scale is going to have to be a little bit more interesting, I think. Let's go 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. You know what? I think we can do better. Let's do, I think we can do better. Let's do a scale of, how high up does that go? So let's do 1, 2, 3. Let's do negative 1, negative 2, negative 3. And then 4 would be out here. I don't think we'll get that. 4 is 256. My scale is going to be huge for that. So let's go up by, what seems reasonable here? Let's go up by maybe 4s? No, let's go up by 2s. So that'll be, well, make that 4, make that 8, make that 12, make that 16, make that 20, 24. I'm definitely not going to be able to sketch them all in here, but I'll get a rough idea of what's happening. So the easiest one to start with is 0, 1, right? 0, 1, 1, 4, and 2, 16. They're going to be the easiest to put on here. So 0, 1 is here, and 1, 4 is here, and 2, 16 is here. So we see this pattern. 3 is going to be 64. It's going to be way up here. So we just sort of show the pattern, right? We're not going to get them all on there, but there's that pattern. And then going this way, negative 1 is a quarter. So that's really down here. And then 1/16, that's really in here. I'm not going to be able to show all those. So what we do is we fake it. And we just show a line getting closer and closer to that horizontal asymptote, but not really getting to it. And we can throw a value up there to sort of help us. That's negative 1 and 0.25. And this would be negative 2 and 1/8. So it's going to be even closer. And that's negative 3 and 1/16. Oh, that's not 8th. I'm sorry, that's 16th. So that's even closer. Okay? So what's the domain and range of this function? Well, the domain, we could have had any values of x at all. And the range, once again, is greater than 0. And it's an element of the real numbers. So this is your domain. This is your range. What are the x and y intercepts? Well, there are no x-intercepts. It doesn't cross the x-axis. The y-intercept? Well, that's going to be wherever x equals 0, and x equals 0 at 1. So 0, 1. And that's true for all of your exponential functions. Because if you have something that looks like this, where a can be any number greater than 0, and a cannot equal 1, but b can be anything at all, whenever, not b, and x can be anything at all, whenever x equals 0, this whole thing will be a to the 0, which must equal 1, which means for every single base, no matter what it is, it's going to be a value of 0, 1. Intervals of increase and decrease. Well, we have to look at left to right. So moving left to right, and as x increases, this way to positive infinity. So that's what this means. As x is increasing to positive infinity, you'll notice that y is increasing to positive infinity. And that just means that it's increasing everywhere. And that's probably the best way to do that. You could also say that y is increasing on the interval of x between negative infinity and positive infinity. And you can't put equal signs on there because you can never equal infinity. Infinity is a direction, it's not a number. You can't ever have infinity of something. Find any asymptotes. Well, there's a horizontal asymptote right here. And it is at y equals 0, or the horizontal axis. All right, summary. If a is greater than 0, if a is greater than 1, the function is always increasing. The asymptote is the x-axis, and the curve approaches the negative end of it. What? If a is greater than 0, then the function is always increasing. The asymptote is the x-axis, and the curve approaches the negative end of the x-axis. So what they're trying to say is that if you have y equals a to the x, and if a is greater than 1, you're always going to have a curve that looks like this. It might rise steeper than others depending on that a value, but it's always going to have a horizontal asymptote at the y-axis. It's always going to cross through 0, 1, and the curve approaches the x-axis going this way. So as x approaches negative infinity going this way, you'll notice that y is approaching 0. The curve is getting closer and closer to 0. On this side of the graph, as x is approaching positive infinity going this way, y is approaching positive infinity as well. Okay, guys, that's it for this lesson, I think. Oh no, we have example 3, so I'll stop here and then we'll be right back.